In this video, we're going to look at financial maths. Interest. Money invested in a savings account will earn interest, which is usually paid once a year. With simple interest, the same amount of interest will be added each year. So you're only working out a percentage based on the original deposit, not on a new total each year. Whereas compound interest, you add on your interest and then you work out a new percentage value based on your new total. So, example, calculate the simple interest on £500 invested at 6% per year after 3 years. So if we work out 6%, we can do this with multiplying factors, 0.06. So 0.06 multiplied by 500 will work out the interest, and that's 30. So that's £30 interest per year. And if we're doing it for 3 years, we'll multiply by 3 and we'll get £90. So the simple interest after 3 years is going to be £90. Part B, after 6 months, well, if we know it's £30 per year, then after 6 months, it's going to be £15. So the interest earned would be 15. Repeated proportional change. So in the real world, appreciation or depreciation is a continuous process. So for the likes of compound interest, where you get interest earned at the end of year one, you add it on, you get a new total, you work out new interest and add it on, and so on. So each year, a new price is calculated, and in the following years, price is determined from the new price. Either calculate it on a year-to-year basis, so what's the new total at the end of year one, the new total at the end of year two, and so on. Or we can use the formula where the new total, so the new amount, is going to be your principal, which is your starting amount or your deposit, multiplied by 1 plus or minus the rate over 100. So the rate is the percentage rate, and we write it over 100, changing it into a decimal and adding it or taking away to 1, depending on if it's increasing or decreasing, and raised to the power of time. So a car valued at £12,000 depreciates, so that's going to be taken away at 15% for 2 years. What's its value? So we can use this formula where the principal is 12,000, and we're going to multiply by 1 minus the rate, so that's 15 over 100, to the power of time, which is 2. So that's 12,000 multiplied by 0.85 squared, which is £8,670. We could have done this on a year-by-year basis. So we could have done 12,000 multiplied by 0.85. So the multiplying factor would be 0.85, because 100% minus 15% is 85%, as a decimal is 0.85. So doing that gives £10,200. So that's at the end of year one. The end of year two, then we'd apply the same process. So it would be 10,200 multiplied by 0.85, and that will give us £8,670. So using the formula just gets us there an awful lot quicker. Example 18, find the interest earned in an account where 4,000 is invested at 4% per annum. So we can use our formula where the principal, which is the original amount, is 4,000, multiplied by 1 plus the rate, so that's 4 over 100 to the power of time, which is 3. So that's 4,000 multiplied by 1.04 cubed, which gives us 4,499.46. And that's the new total, but we were asked to find the interest earned. So what we need to do is take away the original amount, which is £4,000, and we get that the interest was £499.46. Example 19, in 2015 there were 7,050 girls born in Northern Ireland. This was an 8%, or there was an 8% increase in 2016, and then a 5% decrease in 2017, and a 7% decrease in 2018. What was the percentage change from 2015? So what we need to do is figure out how many girls were born in 2018, and then work out the percentage change from there. So 2016 is going to be 7,050 multiplied by, so we've got 100%, adding on 8% gives us 108%, as a decimal is 1.08. And that gives us 7,614. In 2017, there was a 5% decrease. So it's going to decrease from 7,614. So it's our 100%, taken away 5% is 95%, and then as a decimal is 0.95. So if we multiply by 0.95, we get 7,233. And then in 2018, there was another decrease, so that's going to be 7,233. This was a 7% decrease, so our multiplying factor is going to be 0.93. So we've got 100%. Take away 7% is 93%, so the multiplying factor is 0.93. And that's 6,727. So there were 6,727 girls born in 2018. Now to work out percentage change, it's the actual change divided by the original multiplied by 100. So the actual change is going to be 7,050 minus 6,727 over the original 7,050 multiplied by 100, which gives us a 4.58% change, and that would be a loss or a decrease. AER and APR. APR, known as the annual percentage rate, is the annual rate payable on mortgages, loans, credit cards, and other credit products. So whenever you're looking to borrow money, we look at the APR to compare different rates. AER is the annual equivalent rate, and it's used in savings accounts. So it explains the rate of interest you would earn depending on how often interest is added to your account. So generally for loans, you want a low APR, but for savings, you want a high AER. So compare the cost of £200 for 1 year at 12% APR with the cost of borrowing £250 for 1 year at 10% APR. So if we work out the £200, so 12% of 200 is £24. And £250 with 10% APR, so that's multiplying by 0.10, and that's going to give £25. So the 10% option is going to cost more by £1. Example 21, which savings account offers better value for investing £2,000? So option A, you get 3% AER and an £85 reward bonus. So if we work out 3% of 2,000, that's going to be 2,000 multiplied by, so 3% as a decimal is 0.03, which is £60. Then you've also got the bonus of 85, so that's going to give you £145 in that first year. Whereas option B, we're going to do 2,000 multiplied by 7.5%. So 7.5% as a decimal, 0.075, which is £150. So option B is better. But if you were only saving £100, then obviously option A would be better, because you're getting £85. The interest, if you've got £100 at 3%, is going to be £3. Option B would be £7.50, because percentage, remember, just means out of 100. So that's going to be £7.50. But then adding on the £85 is going to make a big difference there. So option A, if you're investing 100, option B, if you're investing 2,000. Income tax. So the government uses income tax to run the country, so pay for the NHS, maintaining transport systems, the police force, national defence and so on. And it gets income tax based on what you earn. Your tax depends on the amount of income you get. So in 2017, you didn't pay any tax on the first almost £12,000. and then it went up in stages. And the way we can think about this is bar modelling, where we have your full pay can be represented as like a rectangle. You then get a tax-free amount, and then the rest of which is taxable. And then the taxable amount can be divided into subgroups of tax depending on the levels of income. And no matter what income you earn, you always receive the tax-free portion. So if you're earning £1 million a week, you'll still have part of it is tax-free. You'll then fill up the small percentage amount first of all, so it might be 25%. And then you go into the next category and you put in your 40%. And you may, in fact, if you're super wealthy, then go into another tax bracket of 50% or perhaps even more. So in this example, Colin has a tax-free allowance of £13,000. He pays 25% in tax on anything he earns after that. If he earns £21,500, calculate how much tax he pays. So I'm going to represent his £21,500 as a rectangle. So that's his full pay. And the first amount that will come out of that is his tax-free allowance of £13,000. So there's £13,000 as tax-free, which means there's going to be £8,500, which is not tax-free, it's taxable. So this is all 0%, so it's tax-free, whereas the rest is 25%. So to work out how much tax Colin pays, it's going to be 25% of 8,500, which is 8,500 multiplied by 0.25, which is £2,125. So Colin will pay £2,125 total tax. Example 23, Sarah has a salary of £25,752 per year. Her tax-free allowance is £5,225, and the income tax rates are shown below. So let's set this up with bar modelling. So she earns £25,752. She's got a tax-free allowance of £5,225, which means then £20,527 is taxable. So those two amounts add up to her salary. Now, within the taxable amount, so the 5,225 is 0%, what we have is that the first £2,230 is going to be taxed at 10%, and the rest is going to be taxed at 22%. So what we need to do to figure out the amount that goes into the 22% is subtract 2,230 from 20,527, which is 18,297. So her tax amount is going to be 2,230 multiplied by 10%, which is 0.1, which is £223. 18,297 multiplied by 22%, so that's 0.22. Is £4,025.34, meaning the total tax is £4,248.34. So then tax is deducted in equally amounts. So what we can do is we can subtract her tax from her total income. So 25,752 minus £4,248.34. That's going to give us her net salary. So that's £21,503.66. And if you divide that by 12, we'll get her monthly income after tax. And that's £1,791.97. Example 24, Tom uses the following information to calculate his tax. So his total earnings is £84,265. He has a tax-free allowance of £11,000, which means that the taxable income then is going to be £73,265. of his taxable income, there's 3,200 is the first amount at 10%, and then everything from 3,200 up to 42,600. So that means that these two rectangles must add up to 42,600, meaning that we've got £39,400 in the second tax group, and everything beyond that is going to be at 40%. So we know that these two squares or rectangles add up to 42,600. We know that the three have to add up to 73,265. So if we take this away, we get £30,665. And now we have that the first 11,000 is tax-free, the next one is 10%, and then 28%, and then 40%. So 3,200 multiplied by 10%, so that's multiplied by 0.1, is 320. 39,400 at 28%, so that's multiplied by 0.28, which is 11,032. And then we've got 30,665 at 40%, so that's multiplied by 0.4 to give 12,266, meaning the total tax that Tom earns is £23,618. So we're now going to look at a couple of examples on VAT. And VAT is value-added tax, which is another way the government can get money through the sales of goods and items. So Joe receives an electricity bill for £70 plus VAT at 5%. Calculate the amount of VAT charged. So we need to work out 5% of 70. So to do that, we multiply by 0.05. So 5% as a decimal is 0.05. And doing that, we get £3.50. What is the total bill then? So we'll do 70 plus £3.50, which is going to be £73.50. And remember, this is currency, so we need to do currency to two decimal places. Example 26, an electric fire cost £135.66, including VAT. How much VAT was payable? Now, if it's including VAT, that means we've got the original amount plus the VAT. And the original is always 100%, and VAT was 20%. So that means that our 120% is equivalent to £135.66. So we need to work out what 1% is, and to do that, we'll divide by 120. We'll do that on both sides. And we get 1.1305. We need to work out what 20% is, so we need to multiply it by 20. And we get £22.61. So the VAT on the electric fire was £22.61. And finally, looking at exchange rates. So the exchange rate for pounds to euro was £1 to €1.15. So I like to think about that. So pounds to euro, so it's 1 to 1.15. So to get from pounds to euro, we're going to multiply by 1.15. So that means then to get from euros to pounds, we'll divide by 1.15. So it's always quite nice to set it up in this way so that we'll know if we're trying to convert from euros to pounds, we'll divide, or pounds to euros, we'll multiply. So Jim bought a pair of jeans that cost €90. So to get from euros to pounds, we're going to divide by 1.15. So we'll do 90 divided by 1.15. So that's going to cost £78.26. Example 28. So what we've got is that £1 is $2. So the exchange rate from pounds to dollars, we're going to multiply by 2. And from dollars to pounds, we're going to divide by 2. From dollars to euros, so we can see that $5 is €3. So to get from dollars to euros, it's sometimes easier to get to 1 first of all. So to get from 5 to 1, we divide by 5, and then we multiply by 3. So we're dividing by 5 and multiplying by 3. On the euros to dollar side, to get from 3 to 5, we divide by 3 and then multiply by 5. So if we're trying to determine £36 or dollar or 42 euros, the way we're going to do that is change them both into dollars. So £36, to get it into dollars, we'll multiply by 2, and that gives us $72. To get from euros to dollars, we're going to divide by 3 and then multiply by 5. So 42 divided by 3 and then multiplied by 5, and that gets us $70. So clearly then the 42 euro option is cheaper. In our last example, 1 euro is 135 yen approximately. So euro to yen, we'll multiply by 135.457. To get from yen to euro, we'll divide by 135.457. And to get from pounds to euro, we multiply by 1.09608, which means from euros to pound, we would divide by 1.09608. So a car costs £12,000 in the UK, the same car costs 1.5 million yen. In which country is it cheaper? So we could convert the £12,000 into yen. So we change it into euro first of all by multiplying by 1.09608. And then we could multiply by 135.457 to get into yen. Or we could change the 1.5 million yen into pounds by dividing by 135.457 to getting into euro, and then dividing by 1.0968 to get it into pounds. Either way would work. But because we've been asked to see which country is cheaper and by how much, we need to change the 1.5 million yen into pounds. So we'll do 1,500,000. To get into euros, first of all, we divide by 135.457. So that's going to change it into euros. And then whatever that is, we're going to divide by 1.09608 to get it into pounds. And that works out to be £10,102.93. So the Japanese car, so buying in Japan, is going to be cheaper, and it's going to be cheaper. So if we take that from 12,000, it's cheaper by 1,897 and 7 pence.